Okay, this will be the last video, I promise, for patterns and nonlinear functions. This is the last example that we need to look at together, and we will do the your turn problem, and then you'll have summary questions to answer at the end. So what we're going to do in this problem, we've looked at graphs and we've written things out in our own words, but this time we just have ordered pairs. And what they want us to do is they want us to come up with a rule. Now, one thing you need to know is that a rule is the equation. How are we getting 1 and 2? And then how are we getting going from 2 to 4 and so forth? That's what we've got to come up with here. So what we're going to do, one thing that I would suggest, and this is completely up to you, but if you don't like the way it looks here, then take this and put it in a table. Okay, set yourself up an X and Y table, just something very simple that we can fill in these values, and that way we can see everything left to right. So I have 1 and 2, then I have 2, 4, and just keep doing that and fill in your table for each one of the ordered pairs that they have given us in this problem. Alright, so we have all of these. Now, one misconception that we have when writing a rule is a lot of people want to compare x's to x's and y's to y's. They want to say, oh, well, my y's are going up by 1, and my x's, let's see, this one's going up by 2, this one's going up by 4, then we're going up by 8, then we're going up by 16. So you could probably guess that the next one we're going to go up by 32. And you all could extend this table out indefinitely following that same pattern. And that's well and good, and that's really important when analyzing what's going on with your problem or trying to figure out what your graph is going to look like. But when we're trying to write a rule, we don't want to compare x to x to x and y to y to y. What we want to compare is x to y. What happened to this 1 when it went into the function machine so that a 2 came out? And what happened to the 2 so that the 4 came out? And whatever happens in this row has to occur in every single row for the entire function. So my suggestion, because a lot of people get very overwhelmed with trying to figure this out, is I would just focus on this one spot here. Just this one. Alright, so let's think of some equations that when I plug 1 into the equation, a 2 is the result. Okay, some of you all may already have something in mind. Let's actually write them as equations though. Y equals x plus 1. I would venture to guess some of you all said add 1. So you're correct, that is one of them. If I put 1 in place of my x, 1 plus 1 is 2. My y value is 2, and so that works. So that's an example of an equation that works for that one row. So let's try to think of something else that might work. We've used addition. You could use subtraction. You could come up with others. But I'm going to go to multiplication because a lot of people will think of this one next. To get from a 1 to a 2 using multiplication, I could say that I am going to multiply 2 times 1, which is x. X is 1 in this case, so if I plug 1 in place of x, 2 times 1 is 2. So that one works. All right, but let's think of something else, and something I'm going to give you that you might not have ever seen before. And this is actually getting into nonlinear functions and discussing about nonlinear functions, but you all have dealt with exponents before in the past, but you might not have seen exponents that look like this, where the exponent itself is the variable. Now these are two very different equations here, so be careful with those. This is 2 times x. This one is 2 raised to the x power, okay, getting into exponents. If you plug 1 in place of x, you're going to get 2. 2 to the first power is 2. Okay, so there's 3 examples there of equations that work for that very first row. So what I want to do now is I want to come up with some equations that'll work with the second row. Now let me rephrase that. I'm not coming up with new equations. I'm going to see if any of these equations that I built for the first row work for the second row. So let's try the first one. Let's plug 2 in place of x, so put a 2 here. 2 plus 1 is not 4, so doesn't work. Made it through the first row, but did not work with the second row. It has been eliminated. All right, so let's try the next one. Let's plug 2 in place of our x. So make sure you have a 2 here. Visualize it or write it down. And you're going to have 2 times 2, which is 4. So that one works. So I'm going to rewrite that equation here because it worked for the first row and it works for the second row. All right, so let's try this equation here, the third one we wrote here. Let's plug 2 in place of x. 2 times, 2 raised to the second power, 2 squared, I'm plugging a 2 in here, 2 squared, or 2 to the second power. That means 2 times 2, and that also gives you 4. So I'm going to rewrite that equation here. 2 equations made it on to the next round, our second row. So we have 2 possibilities now. Alright, so let's try the third row here. Let's see if these equations are true for the third row. So let's start with this one. This time I'm going to plug 3 in place of x. So I've got 3 here, so put a 3 here. 2 times 3 gives me, not 8, gives me 6. Doesn't work. That one made it to the second round, but it did not make it to the third one. So that one does not work. So I'm down to one possible choice. If this one doesn't work, we have to start all over again. So let's see if this one works. Let's plug 3 in place of x. So this is going to be 2 raised to the third power, or 2 cubed. We talked about cubing things a while ago. So 2 to the third power means I'm going to have 2 times 2 times 2. 2, 3 times. So 2 times 2 times 2 is 8. So perfect. So this equation does work for the third row. So let's see if it's going to work for the next 2. It's made it through 3 rounds here. So let's try the fourth one. Plug 4 in place of x. 2 to the fourth power. 2 times 2 times 2 times 2 gives me 16. So check, it works there. Alright, what about 5? If you plug 5 in place of x, you're going to have 2 to the 5th power. And if you type that in your calculator, if you do that in your head, you are going to get 32. So we have found it. This is the rule for this function. Y equals 2 raised to the x power. So that means I could give you any value for x. You would plug it in for the exponent here, and you could give me the y value for this function. Alright, so take the trial and error and the way we processed this row by row, take that and apply it to your turn question here. You've got your ordered pairs here. Write them in table format if that helps you. And just look at what's going on in the first row. Figure out some equations that work for just the first row, and then try to see, work your way down, and eliminate the ones that don't continue to work until hopefully you've got one that will work. If all of them are eliminated, then you'll need to start over again and figure out maybe where you went wrong. But try to write the rule for this function. Alright, and that concludes our video for, well, the 3 videos for patterns in nonlinear functions. So here are your summary questions. Make sure that you know the difference in linear and nonlinear. This one is graphing to determine linear or nonlinear, so that's like the first problem that we did together. This one's writing a rule based on ordered pairs. This one is writing a rule also, but it's multiple choice. Which one of these functions works for this table? So be very careful there because you do have some negatives, so be very, very careful. Do you know the difference in linear functions and nonlinear? And not only just by looking at these pictures can you tell me, but can you explain to me why you know it's linear or nonlinear? And then for number 5, your error analysis, your classmate says that for this table, y equals x plus 1 is correct. That is the rule or the equation for that table. Well, it's wrong. So describe why it's wrong and then correct your classmate's error. Correcting it means write the correct rule. So tell me what is wrong, where does it go wrong in this table, and then give me the correct rule.